Thank you all for joining us tonight. I'll start off by introducing myself and also introducing our guest speaker. My name is Jacqueline Vera, and I am the Beneficial Electrification Manager for Actera. And our guest speaker for today is Tom Kabat. He is an energy engineer and is a board member for sunwork.org. And then before we get started with our presentation today, just wanted to talk a little bit about Actera. Or I think I'll wait a little bit since more people are still joining in. I'll resume the presentation once the 4 people in our waiting room join us. So before we get started with our wonderful presentation today, just wanted to talk a little bit about Actera. We're a nonprofit organization based in Palo Alto, and our mission is to bring people together to create local solutions for a healthy planet. We've been around since 1970, which is the first Earth Day, and our focus is in addressing climate change while advancing equity, and we serve the 9 counties around the San Francisco Bay Area. The objective of the event today is to inform and support our community in understanding HVAC heating and cooling and what they are, the cost savings of them, and the efficiency benefits of them, and how and when to get one installed yourself. So we're going to go over some Zoom etiquette and best practices. Please stay muted during the presentation. The meeting is being recorded, and if you have any questions, just post them in the chat and we'll answer them at the end of our presentation. So before we begin our presentation, I would like to introduce our presenting sponsor, Peninsula Clean Energy, and I'll pass it off to Vanessa.
Wonderful. Yes, thank you so much. We're so grateful to Actera for planning this workshop, as well as for Tom for presenting. Tom is one of our biggest supporters and leaders around home electrification, and for all of you for joining us. And so next slide.
The reason that we went electric, we wanted to do our part to help the environment. The second was the rebates that are available to us right now that make this project affordable. Our gas heater was from 1962. And so we knew that we needed to replace it. Here's our heat pump mini split. One of the cool features of having a mini split in our home, we're not in every room at all times. And so this one is just heating the room that we're in. So it's more efficient in that way. We've never had air conditioning in our home, and we didn't feel like we needed it. When we were replacing this system, now we have air conditioning to boot, and we didn't have to pay more for that. That's like icing on the cake. This is our heat pump water heater.
Okay, you can pause here,
Jackie. Heat pump water here with the
Pause it there?
Yeah.
Okay.
Yeah, so wanted to start us off by showing one of our customers who recently installed and took advantage of Peninsula Clean Energy's rebates, and just to show, some of the real benefits and ways that your neighbors are going electric. So I'm glad you all are here. Next slide, please.
The reason that we went electric, we wanted to do.
Thank you. And so to step back a little bit, I'll introduce who we are. I'm with Peninsula Clean Energy, and what we do is we are a local public agency that provides clean energy at lower rates for the entire San Mateo County, as well as the city of Los Banos. And so we were formed in 2016, really with the mission of fighting climate change and reducing our greenhouse gas emissions. And the way that we do that is by providing clean electricity as an automatic benefit of those living in San Mateo County. And so the programs that I'll talk about today apply only to residents of San Mateo County or the city of Los Banos. But if you do live within the Bay Area or even within California, you are likely to have a local electricity provider similar to us, such as San Jose Clean Energy or Silicon Valley Clean Energy. And so I encourage you to check out their offerings as well. Next slide. And so here's some of the ways that we've partnered with our community to realize benefits around clean energy. So not only do we provide clean electricity, but we pass on a little bit of savings to our customers. And across all of our customers since 2016, we have estimated to have saved them $107 million. So showing that you can do good for the environment and for our communities, and you don't have to pay more, it actually can save money. And then I mentioned that our mission is to reduce greenhouse gas emissions. And so that's why I think it's fantastic that in partnership with our community and customers, we've been able to reduce greenhouse gas emissions from electricity by 98% since we started in 2016. Next slide. And so here's a highlight of some of our appliance rebates that are available to homeowners in San Mateo County or the city of Los Banos. And so these rebates on the slide include rebates from Peninsula Clean Energy, but also from BayREN, the Bay Area Regional Energy Network, which if you live in the Bay Area, you may be qualified for. And so I'll highlight, since the topic today is heat pump, space heating and cooling, that we currently have a rebate of $3,500 if you swap out an old gas furnace, and then you can get additional rebates from BayREN and tax incentives and other goodies. And then if you would like, you can finance those upgrades through our 0% loan program, in which you can receive a loan with 0% interest for up to $10,000 to finance an upgrade of your furnace and basically pay back the cost of those upgrades for a period of up to 10 years. And so we're here to help make it more affordable and are really grateful for our partners here to provide education about the benefits and how you can really go about taking advantage of these incentives and benefits. So I think that's my last slide, but I'll be around here if you have any questions for the next few minutes, and really appreciate Actera for inviting us today.
Thank you for coming today and sharing all that great information with us. And I'll pass it off to our guest speaker, Tom Kabat. I'll stop sharing my screen.
All right, well, thanks so much, Jackie and Vanessa. And Vanessa, before you go, I have a quick question. One of the resources I use is the Switch is On rebate finder. And when I use that to look up PCEs or to look up the rebates applicable in my zip code of Menlo Park, it shows a $4,000 incentive available from PCE. And so, I know incentives are changing all the time, and so you may need to work with them to make sure they've got the current information.
Great, thank you for flagging that.
All right, and so anyway, it's a great pleasure to be here with you all and to get to talk a little bit about HVAC, which stands for heating, ventilation, and air conditioning. And I will start screen sharing. I'm going to show some slides. I'm hoping to not take up too much time with the slides and then go to kind of extended Q&A answering people's questions, because we all have different houses with different problems we're thinking about and lots of situations we want to look at. So I want to spend a lot of time in the Q&A, but let's see if I can first show you my slides. All right. Okay, so we'll talk a little bit about heating and cooling and about why to electrify, about what is a heat pump. And then the big issue in them is in these systems, how do they distribute the heat around the house? And then we'll talk a bit about homeowner economics and then policies to support rapid electrification, and then get to that much needed part where you guys ask questions and we have discussion. So the heating and cooling situation for our kind of gentle Bay Area climate is pretty easy in a way. Temperatures are in 1% of the time, they they're outside of, they're below 30 Fahrenheit or above 100 Fahrenheit. The rest of the time they're within those bounds. And so what happens is we've got these nice survivable temperatures in unconditioned buildings. And then we have building codes and motivation to install insulation and to plug leaks in our houses and, weather strip things and do some caulking and sometimes use some of that spray foam to plug bigger holes. And a lot of us have gotten better windows, which help give us a quieter environment. And those also reduce heat transfer. But doing all those things that are kind of building shell tightening, those kind of really stabilize the temperatures in our buildings and bring it down to a narrower range. And then we apply either heating or cooling to add heat or take it out of the building in order to get down to more and more comfortable temperatures. So we're kind of zoning in on this kind of narrow band, which say between 64 degrees, which is pretty cold to me, or fairly cold, and 80 degrees Fahrenheit, which is fairly hot for me. And so when it gets outside of those bounds, I want either heating or cooling to fix the situation. And I notice in my Menlo Park 2-story home, we use about 20 times as much electricity for heating as we use electricity for cooling. So it's I'm only having to use heat or electricity for cooling a couple of days a year, like the 3rd or 4th day of a heat wave, when heat finally builds up and I need to do something. But I just thought I'd share that it's not like an equal weighting of these two things in terms of where the energy goes when I'm trying to meet that comfort range.
Oh,
Okay, so why electrify? Plenty of
Tom,
good reasons.
sorry to interrupt you, but could you put the presentation in presentation mode?
I don't know yet.
You
it
hit play
looks-
on the top right. Hit the
Top.
play button on the top right.
I only see Zoom controls.
It's
See.
it's on the top. There's a circle with a green
Oh, I
triangle.
see. Okay. And is that better for you? So I'm looking at a slide that says why electrify?
I'm still seeing making home electrification plans.
I think you should start sharing your screen again, Tom. Just
Yeah,
stop
so I'm going to
sharing.
stop
Do it again.
share
Reset it.
and try to start share again. Okay. Do you see the agenda slide?
Yes.
All right. Sorry about that. So I'd gotten up to the why electrify slide, and it's basically for comfort. Heat pumps can heat and cool with precision, and they can also dehumidify the air, and that's useful in the summer. And the inverter-driven heat pumps can really zero in on exactly your target temperature, and they modulate themselves to provide just the right amount of heat to keep you within a narrow band. So you can get much more precise comfort out of it. And then another reason is for modernization, to allow you to use kind of sophisticated control that's now available with apps and different Internet of Things type of situations where you can have your system turn on when you're a certain distance away from your house and get it ready for you and things like that. And then also to meet the changing needs as the climate worsens. And so what we're seeing is more need for cooling, and that is changing year by year. And now that we have a smoke season, there are times when we want to seal up the house and still keep it comfortable. And then it preserves the general climate by leadership on clean energy transition, because what we found is that Peninsula Clean Energy was able to provide this very clean electric portfolio as a stepping stone, but nobody's provided a clean gas portfolio, and there really isn't such a thing yet with methane leakage, because methane itself is 84 times as powerful as a greenhouse gas per pound when it's leaked, and it's about 25 times worse to leak it than it is to burn it, and it's bad to burn it. So methane's is kind of our big problem that we need to be addressing in the climate transition, and electrification is the solution. It also kind of future-proofs our homes and gets them ready for the Bay Area Air Quality Management District rules and the California Air Resources Board, that's the CARB acronym, rules that are coming in 2029 and 2031. Those rules will kind of take the gas furnaces off the shelves, and they'll no longer be an option when your furnace burns out. Then people will end up kind of having to do the right thing or go find the black market. So there will be a kind of a change there. Right now, you can legally do the right thing or the wrong thing for the climate. But anyway, all of these things will help us hold to the 2 degrees Celsius rise that the IPCC, Intergovernmental Panel on Climate Change, has been asking us to hold. Okay, so what is this? What is a heat pump? We've been talking about it. It's really a machine that gathers heat at low temperature, changes the temperature of the heat, and then distributes the heat to a place at a warmer temperature. And an example is your freezer. So your freezer is gathering heat that might be only 2 degrees Fahrenheit. And there is, that sounds cold, but it's still got heat. Absolute zero is like negative 460 degrees Fahrenheit. So 2 degrees still has 462 degrees Fahrenheit of heat in it. Anyway, so it gathers heat from your ice box, raises it to a higher temperature, like about 80 degrees Fahrenheit. And in my house, it then blows 80-degree air across my toes under the fridge. And so the freezer is a heat pump, extracting heat from the ice box and pushing it into the kitchen that's warmer. Heat pumps are really efficient too. So they use 1 unit of electric energy to gather about 3 units of thermal energy, and then they deliver all 4 of those units of energy as thermal energy to that warmer place. And so they're very efficient at doing that. Whereas if you were to burn fossil fuels, you burn a unit of fossil fuel and you get maybe 80% of that available to you as heat, and 20% goes up the stack in the hot gases. Okay. Anyway, space heating heat pumps are really just 2-way air conditioners. So if you're comfortable with air conditioners, a space heating heat pump that we'll just call heat pumps for the rest of this presentation are just like an air conditioner, but it's got a 2-way reversing valve to reverse the flow of refrigerant. A little bit of the nomenclature we use in talking about heat pump systems. We talk about unitary systems or package systems, and that's just a heat pump system that has all the components in one box. They're all in one place in the same location. And then the other term you hear, in fact, it came up in the little video. She mentioned mini and split. So split systems are ones that are not in one box. They have an outdoor component and an indoor component, and she showed us pictures in the video. We saw the outdoor thing out in her yard, and we saw the indoor thing up on the wall. And so the outdoor unit has a motor and compressor and one of the heat exchanger coils, and it's the one in the winter that's gathering heat out of the yard. And then it raises that to a high temperature heat, and it puts it through refrigerant lines into that indoor unit that she showed on her wall, that behind the plastic cover on it, there is a fan and a coil. And so the refrigerant heats the coil and the fan blows room air across it and gives you the heat. So that's what, anyway, split systems are when you've got 2 different parts connected by some refrigerant lines. And then we hear the term mini split. So mini, it refers to that thin profile unit that showed in the video. It wasn't a cube, it looked more like a suitcase. So that's the kind of the form factor of the outdoor unit, is what's meant by the word mini. And the alternative to that I call a yard cube. So basically a big cube that you see in some people's yards. And then another term we are using now is the modern heat pumps are inverter driven. So they have an electrical inverter in them and a computer is controlling it. And the inverter is conditioning the power that goes to the motors of the system to give it variable speed. And that variable speed lets it achieve all kinds of different power levels throughout its operation. So it can work really hard when it's trying to catch up with a target, or it can kind of ease along and just keep things in equilibrium. So it's able to do both. So how a heat pump works in the winter is there's this warm liquid refrigerant in it that is returning from the indoor warm coil, like the one she showed on her wall, and it returns and goes to the outdoor unit, goes through an expansion valve, and that liquid has been under a big pressure. It goes through that expansion valve where it gets to expand into a lower pressure coil, and that makes it very cold when it expands. And that very cold liquid refrigerant picks up heat in the outdoor coil, and it vaporizes or evaporates, same thing. And so then it's turned into now kind of cool vapor, and those cold vapors enter the compressor. They're kind of being sucked into the compressor, which is a motorized thing that's sucking in that cold vapor, and it compresses it. When it compresses it, the gas gets hot. And so it's concentrating all the molecules together, and they're jiggling, and that, jiggling molecules compressed together is what we perceive as hotness, temperature. So anyway, the hot gas moves to the warm indoor coil, gives up its heat to the air in the room through a heat exchanger, and the cycle just continues in a continuous flow. So that's a heat pump. In winter, it just does the opposite flow direction in summer to pump heat out of the house to the outdoors. Okay, I mentioned the big issue in design of these systems when it comes to your home is what kind of heat distribution will you use? And so central systems are heat pumps that replace the furnace with an air handler box, a big gray box, the same size as the furnace, and it's got a fan just like the furnace had, and it's got the heating or cooling coil in it. And that coil can do both things. It heats in the winter, it cools in the summer. And so that thing just blows air into your ducts, just like your furnace has been doing. And the ducts go to the rooms. And so you get all that heat distributed the way you're used to. So that's a central ducted system. The middle bullet there is a ductless system, like the one in the video she showed. She had a little unit on the wall. It doesn't rely on ducts to distribute the system. To distribute the heat. The heat is being distributed by little copper refrigerant lines to that thing she showed us. That was an individual head unit in each room. And she was mentioning one of the benefits was she gets zonal control. She gets to heat some rooms and not others to keep herself comfortable and efficient. And then there's kind of a hybrid between those two. They call mini ducted systems. So it's got a head unit, but it might be, say, in a little space over the hallway, and it might have a couple of short ducts running out to 2 different bedrooms and a bathroom. And so, but not a big duct system like my house used to have. Okay, now slide 2 of how to distribute heat. What are the advantages and disadvantages? So the central systems can replace the furnace with that air handler box, and it uses the existing under the house ducts, so it can be an easier installation. It's generally limited in our climate to about 3 tons of heat pump size. Oh, and a ton, okay, a little more nomenclature, that refers to the thermal power of the heat pump. It's 12,000 BTUs, British thermal units, of energy per hour. And so 1 ton is 12,000 of those. So 3 tons is 36,000 BTUs per hour. Oh, and a BTU, that's about the amount of heat you can get off a kitchen match. If you were to burn a wooden kitchen match all the way, you could use it to heat 1 pound of water, 1 degree Fahrenheit. That's what a BTU can do. Anyway, so that's down into the weeds on when to use a central system. It's when you can accommodate less than 3 tons to meet your needs, and you can fit it on your good condition ducts. I especially like doing it when the ducts are in the crawl space, because that's a nice gentle place for the ducts. I'm not as happy doing it when the ducts are in the attic, and the reason is attic-based ducts lose more heat. And The reason is the attic is colder than under the house in the winter. And the other thing is that even when the unit's not running, hot air from the house rises up into the ducts and loses heat in the attic. But that doesn't happen under the floor. So I have a preference. If I'm going to have ducts, I like them under the floor. If the house has attic ducts, I'm more inclined to explore designing away from the ducts and going ductless. Okay, and then you see the middle bullets talking about the ductless units. You can skip the ducts and avoid the duct losses. And duct losses are often about 20% of the total heat losses of the house. And the other nice thing the lady pointed out in the video was it gives her zone control. And then the mini ducted systems are, again, kind of halfway between. One thing to do when you're talking with your contractor about sizing these heat pump systems is to really work on aggressively shrinking the size of the system. Contractors may want to grow the job and install a bigger unit, to sell you a bigger unit for two reasons. One is more equipment that they are able to mark up means more profit on the job. So it helps them grow the job. And the other reason it would be that a more powerful unit can be more like a rocket and recover faster and prevent any disappointment from customers who have to learn to use the heat pump different than they've been learning to use the rocket furnaces we have. Now, our furnaces that we're living with, most of them are massively oversized, maybe at 2 or 3 times as big as they need to be. And you can kind of tell that because on the coldest day of the year, they're not working the whole hour. They work for 10 or 15 or 20 minutes and they turn off and they coast. And so your house kind of overheats in those 10 or 15 minutes and then coasts and then undercools and they turn back on again, 30 minutes later. So there's 3 different methods to size heat pumps. One is a rough rule of thumb of so many square feet of floor area per ton of heat pump. And you see a lot of that online, and it's just very crude and doesn't take into account our gentle climate that's not very hot or cold. Another is a more detailed calculation method they call manual J, and it's a time-consuming bottom-up calculation with a big guess on air leakage and occupant behavior. And then I like using that bottom method there to take a look at the PG&E data of what is the day that had the highest gas use in the winter, and I find that day and I find how many therms of gas it was, and then I use that to size a heat pump that can meet all of that heat need in 12 to 16 hours. And so this slide, you'll get a copy of the slides, and so you can look at the calculations I would do. But in my example calculations, if they were using 4 therms of heat on a cold day, say December 21st, and I'd subtract out a little bit that was probably water heating, maybe there were 3.7 therms of heat for heating that day, convert it over, it's about 25 ton hours of heating, because I told you about that 12,000 BTUs per hour. And I noticed, okay, we could get by with a 1.5 ton unit, and that would run 17 hours on that cold day to meet their load. Or if we went up to a 2 ton unit, it would run for 13 hours and meet their load. And so if it got even colder, it would just run more hours to meet their load. Okay, so homeowner economics, one idea is to do some shopping. And what we found when we were doing the study for San Mateo County was differences in contractor bids. And so if you got the best bid out there on your first try, you don't save anything by getting more bids, you just get more confirmation. But if you got the average contractor on your first try, you might save $2,000 or $3,000 or $4,000 or $5,000, depending on which contractor you got on your first try. So it makes sense to, if you value money, and not all of us do, but if you want to save money, you may want to talk to several contractors and see who you're a good fit with. And then there's lots of incentives these days. It's kind of confusing. We'll go over some of those. I'll show briefly a little bit of cash flow analysis. And I want to mention that PCE, Peninsula Clean Energy, has 0% $10,000 loans that you can repay over 10 years. So that can make financing these things pretty affordable. Now, here's the number I was telling Vanessa I got off the Switches On website today. It said that PCE had heat pump incentives of $4,000. She mentioned $3,500, so I may be $500 off here. But then there's a program called Tech that's statewide. They offer a $1,000 incentive. BayREN offers another $1,000 incentive. There are currently federal tax credits for 30% of the remainder of the costs. Those are capped at $2,000 each year. And this each year idea is, if you're going to do your heat pump replacement this year, you may want to wait until next year to do your heat pump water heater replacement, because both of those have competing tax credits that want to fit into that $2,000 a year space. And so if you used it all up on the heat pump, it wasn't there in 2023 for you to use twice and get the water heater one, but it's there in 2024 and 2025 and there, for 8 years after that. So people may want to stagger these two investments, the water heater and the furnace, the heat pump replacement. Anyway, totaling up these incentives here is about $8,000 on a 2,700 or 12,000, we'll call it 13, a $13,000 or higher cost device. And anyway, the net cost after the $8,000 would have been $5,000 if it was on a $13,000 invoice. And excuse me, yeah. So yeah. Oh wait, let's go to a 50. Now we'll move to the bottom line is a $15,000 example, and the net cost would be $7,000 after the $8,000 of incentives. Sorry about all the numbers. It's a time I like to call peak incentive. Hopefully it'll settle down and there will be fewer incentives in the future. But here's a little stack of what they look like from the top down. Here's an example with a $16,000 example cost and 3 different territories: PCE for San Mateo County, City of Palo Alto Utilities next door to me, and Silicon Valley Clean Energy for most of the rest of Santa Clara County, except San Jose and Santa Clara. Anyway, so the blue bars are the net cost after the incentives, and then the incentives, you can see the next one up above the blue bar is the federal $2,000 tax credit. And then there's federal upfront incentives that may start in 2024 for middle income and low income families. I didn't show any of that here, but it's $4,000 for middle income families and $8,000 for lower income families. So it's a big incentive, not shown on the chart yet because it's not available today. But then today we do have the tech incentive of $1,000 and the BayREN incentive available outside of Palo Alto. And then the CCE is PCE in the Peninsula and SVCE in Silicon Valley. So here you can see it depends on where you are. What is the net cost? And this is the same type of information now just shown for the naked cost with no incentives, and then the cost after incentives in the 3 territories. In Palo Alto, it's reduced some. In SVCE, it's reduced even more, and in PCE, it's the lowest of them all. It's on the order of half the cost of the invoice. Okay, so how do you compare apples to apples when you're looking at heat pumps and deciding, what should I do with my aging furnace that's either broken or about to break? And what do I do when I want air conditioning? So you have to think of what is the counterfactual, we say in analysis. It's what is the path you don't take when you go and take a heat pump? And so you could look at, do you get a new central heat pump? That's what I'd hope you want to do. And so it might cost, and here's a new example, $17,000 minus $8,000 in incentives is a $9,000 net cost. Apples to apples, it's going to give me heating and cooling. I need to compare it to, do I get a new furnace and a new central air conditioner? Now that would give me heating and cooling, and it might cost $18,000. It's apples to apples. This other one, after incentives, cost less. And then, I could have done a multi-zone ductless system, and that might have had a higher price tag, but it still costs less than getting a furnace and central air conditioning. Oh, I could have done a new furnace plus new window air conditioners in each room, and for $12,000, and there's no incentives. And then I could have done a new furnace and just sweltered in the heat. And so I call that the apple to raisin comparison. So there's all kinds of choices you have, and you just have to decide what you want to do there. Okay, that's fine. Here's a fun one from the 10 home study in San Mateo County. The blue bar shows the net cost of buying a furnace in these 10 different homes. And these are code names that I used to know. And the red line, when you see it, is here's a red line. It's about zero cost for low income family getting a heat pump. And here it is, zero on that house and zero on that house. The gold one is middle income homes net cost of getting a heat pump. And the green one is high income homes net cost of getting a heat pump. And so what you see is it's kind of all over the place. In general, just going with a gas furnace option was more costly than getting the heat pump option, and the net cost of getting a heat pump option depended on those federal income-based incentives. And so that's the difference in the 3 bars there. And again, I keep whining about peak incentives. There's so many out there. And so here's a table trying to organize them, and I'll have to work on this $4,000 number that I got today and make sure I get the right number from PCE. Anyway, here's an example with 3,500 in the PCE incentive quote cost. One way to look at it is for this example home we had in San Mateo County, a $15,000 heat pump bid minus the incentives gave a net cost of $4,600. And that, let me just see, that did use the middle income incentive of $4,000. Without that, it would have been $8,600. All right. Little cash flow example. It's kind of an eye chart problem here, but in doing the simulation of cash flow, we looked at the Public Utilities Commission report on where they think gas and electric rates are going. And so that helped us generate the black line, which was, what if you stay on gasoline, on natural gas, and don't electrify more of your stuff? And you go on the black line of expense over the years, and this is showing 30 years across the bottom. And then the lowest line on here was if you electrified everything and put solar on and didn't use a battery. And so it was able and financed the incremental cost. So this is just looking at what are those cost increments? Can I finance them? And if I'm paying my finance charges and my utility bill and my gasoline bill, what is my total cost outlay? And so it was cheaper than not doing it. Okay, so that's kind of all of our individual situations, looking at our home stuff. And then, since we're here on an Actera sponsored event, I wanted to speak briefly about supportive strategies for all this. So what we need to help make this easier are streamlined city permit applications for electrification in whatever city you're in, trying to make this stuff easy. And the city of Menlo Park, as an example, has waived the electrification permit fees for electrification projects. And I hear in Palo Alto, they put electrification projects at the front of the permit checking line to get them approved quicker. Okay, so the other thing we can try to support is making incentives available at the point of sale, like at the store. So it's not an after the fact thing, it's built into the price. And that happened a lot with LED lighting incentives. You didn't have to fill out forms about your light bulb. The key incentives were just built into the price that the store offered. So the store got paid the incentive and they were able to put a lower price on the shelf. Anyway, requiring electric appliances in existing buildings so that people don't install the gas things when things fail, that they install the right things, and requiring it when homes are remodeled. If they're going to mess around with the systems, put in the ones that preserve the climate, not the ones that trash it. So one other idea is to have policies that prohibit the sale of one-way air conditioners. For just a couple $100 more, the one-way air conditioner can have the reversing valve and be a two-way device, but it has to be built in from the start. So it's hard to retrofit that, but if they pick it from the start, everything works well. And then we need more training and incentive programs for the workforce to help the electricians, the HVAC installers, and the plumbers all get familiar with electrification and become the advocates for it and help people protect their electric panels. Now, in the chat, hopefully we'll post some of the resources and links to resources that you can get. I also should send along a link sometime to the Ask Sean show, and I help out with that show where Sean Armstrong and I do case study examples for people. They send us information about their houses and ask about their electrification dreams, and we help find the products and designs that we think will help meet their needs. There's also a couple of concierge services around. I'm mentioning two here, Emerald Eco and Quit Carbon. They have both been operating in the area for a while, and there may be more. Anyway, we have gotten to the Q&A part, so I'm going to stop sharing. And,
If you have
open
any,
it up.
we have 3 questions in the chat. Let me see the first one. What Rebecca says, can you talk about the difference between an air to water
I do
HVAC?
see that question, so
Okay.
I'll read it out. Can I talk about the difference between an air to water heat pump versus an air to air heat pumps? And so far, I've only been talking about air to air heat pumps for space conditioning for HVAC. But Rebecca's interested in another one. Let me just read the rest of the question. Yeah, so for I mentioned the big deal was how do you distribute the heat? And so she's asking about what about homes that use hydronic heat distribution, like radiant slab floors or radiant wooden floors where they have tubes under the floor with warm water circulating in them. And so those are interesting systems. I don't know as much about them, but there are some on the market. I was just talking to somebody who's using one called a Chilltrix brand system, and it heats water for the floor and circulates it under there. Unfortunately, I don't know too much about them. And I just want to also say it's possible to use 2 systems in tandem, and in thinking about the problem people face in Eichlers that may have those floors, the classic Eichler thing to do is to try to heat the whole house by heating the floor, by overheating the floor. And then an alternative to me seems like it might be to have a mini split ductless heat pump that tries to heat the air in that building while you sort of heat the floor, you semi-heat the floor so it's comfortable on your feet, but it's not enough to heat the building, and then you heat the rest of the air in the building with the air-to-air heat pump. So anyway, I'm not terribly familiar with the hydronic systems. I know they're more complex, but some people love them. You go look for. Let's see.
Someone also asked, why are central systems limited to 3 tons?
Oh yeah, thanks for asking that. So that's just a rule of thumb we picked up from talking to contractors about how much heat pump heat can they move through an existing gas-fired duct system. So the gas-fired furnace produced very hot air, say 130 degrees Fahrenheit, and it didn't take too much 130 degree Fahrenheit air to deliver all the heat it delivered. But a heat pump system might only be producing 100 degree air or 110 degree air. So it's going to take more air flow through there at a higher rate to deliver the same heat. And they kind of max out when they're delivering about that 3-ton level, which is 36,000 BTUs, whereas your furnace might have been able to push 60,000 BTUs through that ductwork. The heat pump can't move the air fast enough to push more than about 36,000 BTUs. If it did, it just gets too loud. It starts creating a noise in the ducts. So we don't want that. So anyway, that's it. It's if you want to reuse your ducts, it's great to be at 3 tons and less. So they're nice and quiet and don't leak much.
And the next question is, do you maintain a list of vendors/installers who are familiar with and work with rebate programs and guide to solutions with all the rebates in mind?
I sure don't do that. I'm just an engineer. And the Switch is On organization does something like that, and the concierges do something like that. So you might want to look at those. And maybe the community choice energy groups do it too. So you might want to check in with PCE, with BayREN, with SVCE. Yeah, I'm not a shopper. I'm just an engineer.
And the next question is kind of follow up to what you just said. What are concierge services?
So that's a company that will help you find a contractor and get the project done. So they'll kind of come in as a middle person to help select and manage things. So they help you navigate the process.
And then next question, what is latest on when in 2024 the IRA rebates for heat pumps will become available in California?
Yep, so that's up to the state, and I haven't heard a new update. The last one I heard was late 2023 or early 2024. And the other thing I'm thinking from doing my own calculations about it is the tax credit incentives are different than the upfront incentives. And this question was about the upfront. The tax credit incentives are continuous. They run across all the years out through 2031, and they're continuously funded there were new taxes also in the Inflation Reduction Act. Okay, but the upfront incentives have a first round limited pool of money. And when I look at that, I kind of expect them to last about a year in California, that size of the pool of money. So hopefully it'll be the low income folks who go get it, and that maybe that can last a bit longer, but I don't think that'll last long. And then hopefully a Congress in the future will refund that again and keep it going.
The next question.
So vote well.
So the next question is it typical that a 1960s ranch home needs to increase the size of the air return ducting when installing a heat pump?
Okay, so yeah, that's where one of the constraints often is on the return air. So your current furnace kind of sucks air off in the hallway. There's a grill in the hallway, and that's called the return air. And often it's the return air size that is one of the constraints on airflow for a heat pump. And so that's where we might hit that limit. And so, for staying at 3 tons and under, what you're trying to do is stay within that constraint so you don't have to modify the return air. And so I like trying to obey those types of limits and avoid adding to the project by avoiding upsizing that. What are the ways you avoid upsizing that? Well, just being more courageous about having a smaller heat pump that you let run more hours per year, or more hours per day on the peak day. That's one way. And another is to look at adding more insulation or doing more air sealing to reduce the heat needs of your house that lets you get by with a smaller heat pump, or what other energy project you might have. But attic insulation increases look like one of the more economical things for keeping from having to upsize the heat pump. And the other thing is that the cost of the heat pump machine itself has a kind of a break point. Up to 3 tons, they're relatively simple things with 1 fan, and above 3 tons, they're a taller stack with 2 fans and 2 coils and a little more machinery out in the yard. So another reason I want to avoid upsizing.
Then a quick thing that I want to say is I posted in the post-event survey in the chat. Please fill it out before you leave. And the next question is, someone's been told that their duplex doesn't qualify for any rebates because they don't have an AC. So are you?
Yeah, and so what, well, I always wonder when someone's been told these things, first thing people need to tell me about these cases is, where do you live? What city, what utility? If you tell me a city, I can guess the utility. Anyway, that helps me center on whose policies are you looking at? And yeah, I can't remember who's got a policy that requires you to have an air conditioner to get a heat pump incentive. So anyway, yeah, I'm not sure about it, but it sounds worthy of more exploration. It might not actually be a hard constraint.
Next question is, this person has a 2-story house with a furnace located in a small attic room. Can this be converted into a heat pump system? Second floor ducts and ceiling, first floor and crawl space under the house.
Yeah, yeah. So in that kind of case, getting a central ducted heat pump into that small room would be typically the same size, dimensions, same inches of dimensions of the existing furnace. And so it would connect into that ductwork and flow. And then I keep mentioning this idea about like a 3-ton limit on existing ductwork. And so that, I'd probably want to try picking a 3-ton setup there. And let's say that wasn't quite enough thermal power for you. After a year or 2 with it, you decided you wanted more power. You could always add another 1 ton or 1.5 or 2 tons of mini split ductless unit down in one of the the big rooms, like the living room, and then that would add more heating power to it. But I'd recommend going a route of trying to stay to 3 tons or less and use the attic room and put the new air handler in there just right in place of the furnace. You'd need to still find the location for the outdoor unit. Lots of people put them in their side yards or in their backyards. And actually, I've seen some up on rooftops also. So that's another location for them when there's not enough side yard space.
And the next question is, what are the amp ranges for approximately 900 square foot house?
Okay, the amperage, maybe they're asking about what is the amperage of a heat pump that would work in a 900 square foot house. I'll try to answer that question. It's probably about 11, but one of the sources that I hope is getting copied to the chat will be that the NEA, the connection to NEA's air source heat pump product list. And so clicking on that link and looking up any unit you want, it'll tell you the kilowatts of the unit and the amperage of it, or from the kilowatts you can get the amperage. and get those answers, but it's probably going to be around 10 or 11 amps at 240 volts.
So the next question is, looking at insulation under the floor in the crawl space, coastal location, and vapor barrier for prep for a harvest thermal system, heat pump, water heater oversized, new ductwork with insulation. Is the vapor barrier a good idea? Does it trap moisture and create rot?
Let me just think about this as a coastal location. So I'm going to Half Moon Bay type of place. Let me think about it for a second. I think the vapor barrier needs to be close to the room in Half Moon Bay, not out on the outside walls. And I think, I generally think having a vapor barrier close to the wall in our climates, and I count myself into the coastal area, I guess, is a good idea. So let's see. Vapor in most of our California climates, it goes from the inside of the house towards the outside. So you want to put your vapor barrier towards the house where the moisture is. You want to contain the moisture in the house and not let it into the walls. If you let it into the walls, it can condense and become liquid water in the insulation in the walls. So that's why a vapor barrier is a good idea close to the sheetrock in our climate. In parts of the southeast where it's hot and humid most of the year, they tend to go the other way and they put the vapor barriers towards the outside of the wall.
And there's the next question is, are there consultants that can help me navigate this space rather than be at the mercy of contractors? And Rebecca answered about Bayren providing some services. Do you know if
Yep.
there's like other organizations?
Well, the concierge services are one of the ways to do it. So let's say you find a concierge you trust, and then they help you navigate. One thing I'd love for people to start doing is grouping up and actually seeing that there's dozens of you on this. What if folks here organized into a group buy and then helped each other by grouping up as a school of fish to interview contractors together and help sort through the shopping exercise. So kind of a group shopping. And you can maybe get some kind of a bulk discount by making life easier for the contractor too, by having them, get several deals out of a couple of meetings.
So this next question, someone got a new gas heater and AC installed 2 years ago. It cost $13K to do so. They didn't know about heat pumps. Is it worthwhile to consider changing to an HVAC? Do not have solar yet, but considering solar. Already changed my gas water heater to HPWH last month. I also checked with my AC installer. He said it might cost around $8,500.
Yeah, so it sounds like this person's done a bunch of work and they found that they've got a quote that it may cost around $8,500 to do this work, and they're asking, is it worth it? And that's a personal question. Is it worth it to them? It probably could give them a little better winter comfort from the heat pump, and it definitely would decrease their emissions, which I value, and so I'd be grateful. But yeah, I got rid of a 3-year-old gas water heater to get my heat pump water heater in 2016, and for me it was worth it, but I had the option. I could have waited and kept polluting, so it's just a choice.
And the next question is, where can I get a blower door test?
Yeah, I don't know. Good. I would Google online and look for that. look for a firm that does that. So a blower door test is part of a comprehensive energy audit. It's more popular and more necessary in more severe climates than ours, where the outdoor air is at more extreme temperatures. I started by telling you that our climate's pretty gentle, and so air leakage is on average a gentle problem. It's a problem, but it's a gentle one. But if you go to a tough climate like Minnesota, air leakage, the same air leakage, is a big problem, and a blower door test would reveal a bigger cost issue to them. So anyway, I'd Google it and look for who provides those services, and see if you want to avail yourself of them. To me, it makes sense, if you're going to do the blower door test, to have somebody simultaneously be fixing the leaks while the test is running, and be patching and caulking things and foaming things, and see the metered leakage go down, and just keep fixing things until the rate of fixing things, the cost of that per hour is hitting diminishing returns and not shrinking how much air leakage you're reducing. But that's, for me, just an economic optimization question. But I don't know the firms who do it here.
The next question is 1975 house. It was recommended to get blown in insulation and in all the walls. Is it really necessary? I have double pane windows, opening all the holes and repatching between every fire stop. Is that really going to help with the new system?
Yeah, so it will help some. I was doing a few little calculations earlier today on that. You can shave maybe a half a ton off the system size by insulating the walls of a house like that. We did that for my daughter's house up in Portland, but it also we needed to do that for noise issues in her neighborhood. And so, is it worth it? I don't know. It can help. It can shave somewhere around, a tenth to a half a ton off the equipment sizing needs by doing it. And I agree with you. It's a bunch of work. I think, for us, it cost maybe $9,000 or $10,000.
The next question is, do the outside units make noise that will annoy me and my neighbors?
So they make noise, and it won't annoy you. So inverter-driven machines, they make noise. They tend to be quieter, and they tend to operate in a quiet range, and they don't do the annoying bang on and bang off like old one-speed air conditioners do. And so that jarring bang on and bang off is probably the most disturbing part of their noise cycle. But then they're just on at one roar, whereas an inverter-driven machine can be a high-quality machine. They have decibel ratings on them for the sound levels. So compare those, and try to position it in a way that's not going to be too annoying, like not facing your neighbor's window. Try to slide over to a place where it's not facing right at them, or you can get it, filter it through some bushes or a fence or something that baffles it a bit. Anyway, so yeah, there are different sound levels for different machinery, so take a look at those decibel ratings on them. But in general, mine is very quiet. Oh, and actually, so my heat pump at my house, I did a do-it-yourself thing. I didn't even show that in the examples, but it was, about $2,400 to buy a Mr. Cool brand do-it-yourself mini split ductless heat pump and install it myself. And they have couplings you can fit together, and you don't need the fancy refrigeration tools because the refrigerant is all sealed away behind valves. And then you connect it all up, and it's the line set has been pre-evacuated, and then you open the valves and it lets the refrigerant out of the container and into the system. And it's been running nice for a couple of years. So that's how I I think I fully electrified my house without incentives for about $7,000 or $8,000.
So someone's saying that unfortunately Bay Run seems to be the only game in town in Pacifica, California. What do you suggest? Because they have the if I guess they're talking about the if you don't have an AC, you don't qualify for the rebates.
Yeah, so some, I don't know exactly the situation they're looking at, but I did see when I looked up the size of the Bay Run incentive, it was only $1,000. And so why not ignore it? And do, and meet the Peninsula Clean Energy requirements, who also serves PCE. Oh, and you might want to become a Peninsula Clean Energy customer if you're one of the 1 or 2% who opted back into PG&E. Maybe you can opt back into Peninsula Clean Energy to get their big incentives. $3,000 for heat pump water heaters, another $3,500 for heat pump space heating, and that big loan. So, it kind of pays to be a PCE customer. So that, maybe somebody opted out and that's why they think Bay Run's the only game in town. But the tech program also would apply to them and have $1,000 incentive.
I believe that's all the questions. If anybody has any more questions, please put them in the chat, or if we didn't see your questions, please put them again in the chat. And also a reminder, please fill out our post survey that we posted in the chat. And thank you everybody for coming. And thank you to Tom for doing the presentation. And thank you to Peninsula Clean Energy for being our event sponsor.
Yeah, thanks everyone for the opportunity to talk about this stuff, and good luck with the electrification and keep on the transition.